So as you read this question, you kind of recognize that this is a Venn diagram, a double Venn diagram problem, and that's what I'm going to use to put a structure to this. And we're told that this entire box, that's the total number of people, is 110. 65 own stocks. So again, I put it outside. That represents that entire circle. 82 bonds. Question is, how many of the people surveyed own stocks but do not own bonds? So that's this region here. And I'm going to assign that a variable and try to write everything else in terms of x, which means that people who own both stocks and bonds would be 65 minus x, because that entire circle is 65. And then I can also find this category because I know 82, I'm assigning y for now, must be equal to y, which is bonds only plus the overlap. So that's 82 minus 65 plus x, and that would be 17. So I can remove and get rid of that variable and just write it in terms of x. I can also figure out this, that own neither stocks nor bonds, because all these four regions, this is stocks only, bonds only, overlap, and neither, have to add up to 110. So again, I'm going to just call it another variable and try to express it in terms of x. X plus 65 minus x. And I don't really use the Venn diagram formula. You just add the individual quantities, which they are equivalent. So wait, no, not 82. This is 110. That's the total box. 65 and 17. That's 82 plus x plus z is 110. So z is 82. So 28 minus x. So you can just literally just replace that here. Yeah, so actually, an easier way would have been, I did all this work, I just realized this is x. That entire is 82. So x plus 82 is the entire circle here. And then this is the part that's missing. I just have to subtract that from 110. So different ways of doing it. And you would get 28 minus x. But sometimes, this doesn't require me to think too much. This is a little bit more, I guess, stress on the brain. So now we have all these regions, and I can see some students saying, is it needed to do all this work? I personally do that. Sometimes, it would be easier also to kind of work with the statements one by one. That's also a potential approach. Statement 1 says 50 of the people surveyed own both stocks and bonds. So 65 minus x is 50. Well, we know we can figure out x. It's 15. So 1 is sufficient. 2 says 13 of the people surveyed do not own either stocks or bonds. So that's 28 minus x is 13. And you will see that if you compute x, that also works out 15. So anytime each statement alone is sufficient, the values you get will always match. It's not like you'll get 15 here and 20 here. Now, if you do get two different values, that's most likely because you made some mistakes, either some sign mistake here or some algebraic step. So on easy enough problems, I actually do the computation where I kind of suspect that it will be each statement alone is sufficient, because once I see that I'm getting the same value, it gives me further confirmation that I probably did everything correct. So that's kind of how I actually approached in the exam. You can certainly do them one by one by taking the information given in the statements. That's also easy, and perhaps it's easier because you don't have to do all this algebra. But what I will comment that this kind of an algebraic approach becomes very important as the statements become more and more convoluted, which they do. For example, they might say the number of people who do not own either stocks or bonds is 1/3 of the people that own stocks only and bonds only. So they get into those types of statements. And I think it's easier to do that once you've labeled everything and to set up those relationships. So, but for this question, I think it would have been also easier to just take each statement alone and work with that. So summarize, the answer here is D.